So our chapter on inverses. So far we've looked at graphing, we've done evaluating, and we talked about a little bit of application. So now we're going to look at actual functions. First thing we're going to go over is proving that two functions are inverses of each other. The whole purpose of an inverse, again, is to cancel out the original function to take us back to our original x value. So let's take a look. If we were to take our function and plug the inverse into the function, it should take me back to x. Remember, my function and my inverse cancel out. But if this relationship is true, then the opposite is true. If I were to plug in my function into my inverse, that also has to take me back to my original x. That's how we're going to prove that two functions are inverses of each other. This is called composition. We're plugging one function into another. So now I'm not going to say, hey, this is the function, here's its inverse. That defies the whole purpose. What we're going to do is I'm going to give you two functions, and I want to know, are these two functions inverses of each other? For example, if I have g of x equals 4x minus 2 and f of x equals x plus 2 over 4. I want to know if g and f are inverses of each other. So what I'm going to do is I'm going to test this out. I'm going to plug g into f and see if it gives me x. If it does, that's a great sign. I also need to prove the opposite. I need to know that if I plug in f into g, it's going to take me back to x. Both of those have to work for it to be an inverse. Most of the time it's going to work. If one works, the other should, but we have to do it just in case, because there are some cases where it won't. So we don't want to get caught up in that. So what I'm going to do is I'm going to take g and I'm going to plug it in for f of x. So my f of g of x, I'm going to take g and replace my x here. So I'm going to replace that with 4x minus 2 plus 2 over 4. These parentheses, I don't need to multiply, no power, so they really don't need to be there. So now I have a negative 2 plus 2. Those cancel, and I get 4x over 4. 4 divided by 4 is 1, and that leaves me with x. Great start, great sign. So f of g of x gave me x. Cool. So now I'm going to do the opposite. I'm going to do g of f of x. So I'm going to take my function f of x and plug it in for my x in g. So that's going to look like 4 times x plus 2 over 4 minus 2. All right? So here, 4 divided by 4, that's going to cancel, reduce to 1. And then I have x plus 2 minus 2, positive 2 and negative 2, that equals 0, and that leaves me with x. So I've just shown that f of x and g of x, that yes, these are inverses of each other by proving that composition. Order of operations is very important when you do this. Make sure you plug in properly. Just pay attention to the details, because that's where we're going to run into our issues. So let's try my next example. So here I have f of n equals 1 over n minus 2, and g of n equals 1 over n plus 2. So again, our goal is just to prove, are they inverses or are they not? So we're going to do that using our composition. So I'm going to start by doing f of g of n. So I'm going to take this whole function and I'm going to plug it in for n. So that's 1 over n plus 2 minus 2. So right now, nothing's going to simplify, but I have a fraction divided by a fraction. So I'm going to go ahead and copy, dot, flop, like this. Well, those are just ones, so then I get n plus 2 minus 2, which is n. Again, great start. That's right where we want to be. Sorry, my computer went to sleep. There you are. Hi. Okay, so this side works. Let's go ahead and try the other. So now I'm going to take g of f of n. So I'm taking my function f, and I'm replacing n. So that's going to look like this. Wait, f into n. Okay, 1 over n minus 2 plus 2. So if I put that in parentheses right here, that's the n that I just replaced. But again, those parentheses, we're not multiplying or anything, so they're not needed. Negative 2 plus 2, that's 0. So I get 1 over n. So I'm going to go ahead and do my copy dot plot. And that's going to just give me n. So like I said, it's kind of rare or very special cases where if one side works, the other side won't. But we always want to double check. So we always want to test both directions to make sure that those are inverse functions. Okay, good luck.